All right, guys. Welcome to the chapter 10 notes here. And the nice thing about these notes is that it's going to be a lot of the same stuff because we're just doing more confidence intervals, more significance testing, just for different types of data. So now we're looking at two samples, two proportions, two means. And so what can we do with those? So yeah, let's get into it. So this will go a little bit quicker, I think, just because, again, it's a lot of the same stuff. So here, two proportions. This is your hint that we're doing like two samples. And so the reason why I kind of point this stuff out is because when you go to the calculator now, you know what you need to do. You're looking at two sample t-test, two sample confidence interval, et cetera, et cetera. So just kind of keep that in the back of your mind. All right, so what are the conditions? So you're going to notice that a lot of these are very familiar. So we have one, we have random, okay. Two, so you can see some minor changes. So here, both n1, so your first sample needs to be less than or equal to 1/10 of big M1. Okay, so and then you got to check your second sample as well. So N2 needs to be less than or equal to 1/10 big N2. Okay, and number three, okay, you need to check N1 times P hat 1 is greater than 10, and 2, or N1 times 1 minus. Let me write these out actually instead of using the keyboard. All right, so for part three, third thing you got to check. So N1 times P hat 1 needs to be greater than 10. N1 times 1 minus P hat 1 needs to be greater than 10. And then you got to check the other ones. Then you got to go N2 times P hat 2 needs to be greater than 10. And N2 times 1 minus P hat 2 needs to be greater than 10. So again, here, check both. On these, check all four. Okay, so make sure you're just checking all the conditions. So, but again, these are all very similar to what we had before. It's just now that we're dealing with two samples, you got to check it twice for everything. So, so what is the formula for a two sample Z interval? So for P1 minus P2, so you're gonna have same thing. You're gonna have your statistics of P hat 1 minus P hat 2 plus or minus your Z critical times the square root of the standard deviations. And if you go back way to when we started transforming things, remember how we can only add them together and not subtract. So it's the same thing here. So P hat 1 times, I'm going to write Q hat 1. Remember, Q is just 1 minus P hat 1, or 1 minus P. So just to make my life a little easier. N1 plus P hat 2 times Q hat 2 all over N. Okay, and I'm going to write this on the side. Q is equal to 1 minus P. So some people write Q as, or some people just denote 1 minus P as a variable Q. So it just makes it a little easier to do that. Okay. And again, this is to find a interval. Okay. And so then this whole thing here, different color. So this whole thing here is your standard error instead of rewriting the whole thing. Okay, this is your standard error equals SE. And again, your standard error tells you how far the difference in the sample proportion will typically be from the difference in the population proportion. So I'll write that out. SE tells us how far the difference in the sample proportion will typically be from the difference in population if we do many repeated random samples. Okay, so take some time, see if you can figure it out here, see if you can check all the conditions, see if you can come up with a confidence interval using the equation, see if you can interpret it. So yeah, see if you can do this problem. And again, we'll look at that in class. Can you use a calculator, like I've said before? Yes, you can. But again, set it all up, and then we'll go from there. And again, another good practice problem. So we'll try that out. Again, we'll do a lot of those in class. So now we're looking at significance tests versus the confidence interval. Okay, so now, why is it important to randomly assign treatments in this experiment? So again, remember, randomization allows for generalization to greater populations. If you impose a treatment right, then you have an experiment. This is kind of a good recap of chapter 4. Then you have an so then you can say cause and effect. All right, so state the null and alternate hypothesis. So if we're looking at the difference between two proportions, remember we talk about the null hypothesis being the baseline, and so HO would be that P1 minus P2 equals 0, right? That there is no difference. Another way of writing this, or P1 is equal to P2. Okay, that's one way of writing it. And this shows that the proportions are the same, which gives us our baseline. Okay. And then since we believe, read the problem above, more people say yes, our HA will be P1 less than P2. Or I'm going to write this, or P1 minus P2 will be greater than 0. Or less than 0, sorry, less than 0. Since P1 has to be less than P2, then when you subtract the two things, P2 is bigger, and therefore it's going to be less than 0. So here, if we do some percentages here, if we calculate this out, we have a P hat 1 is equal to 14 out of 30. Okay, just get that from the table, which is 0.467. P hat 2 can equal 18 out of 30. Again, from the table, 18, 30. And that's 0.60. Once you subtract the two, P hat 1 minus P hat 2. Subtract those two numbers, you get negative 0.13. Okay, so now the question is this significant? Right? And so now we can look at this, and again, we're going to get to the whole do the Z test, and then take a look at some p-values and determine the cutoff. So that's kind of where we're going with all this. Okay, don't worry about this problem. We'll kind of go to the next one. What are the conditions for conducting a two-sample test? This is important. So what do we need to check before we do all this? Before we actually compute everything. So 1, again, randomization. Again, this should look very familiar to you at this point. 2, it's just slight difference here. So N1 has to be less than or equal to 1/10 of big N1. And now we got to add on that second sample. So N2 has to be less than or equal to 1/10 big N2. Number 3, we got to check all the normalities. So then we got to go N1, all the ones from above. Draw these out. P hat 1 greater than 10. And 1 times Q hat 1 greater than 10. Remember, Q is just 1 minus P. Keep going. And 2 times P hat 2. Again, you got to check all of them. Greater than 10. And 2 times Q hat 2. Also greater than 10. Okay. So you can check the conditions for the tattoo experiment above. Take a look, see if they work. What's the standard error that we use? We've already talked about it. So we have SE P hat 1 minus P hat 2 is equal to the square root of P hat 1 times Q hat 1. Again, the standard deviations added together, divided by M1 plus P hat 2 times Q hat 2 over N2. Okay. And then we can also look at this thing called pooled or combined sample proportions. So I'm going to write some stuff about that in a second. So since P1 minus P2 is equal to 0, just based on our null hypothesis, right? That's our baseline. We can say that P1 is equal to P2. Just move stuff around, right? If I add P2 to both sides, I get P1 equals P2. Meaning that the parameter is the same. Since that's true, we can combine. Since we combine the parameter, we need a way to combine statistics. And so that's going to lead into what this pooled thing is. So hence, all right, so what you can do for pooled is you can say, is P hat C, which is going to stand for combined, is equal to the combined successes divided by total combined. Right. So then if you say X is your success, then you can say the P hat C is equal to X1 plus X2 divided by M1 plus M2. And it's just another way of rewriting these things. Okay. So now what is the actual test statistic? How do we actually compute this thing? All right, so again, remember test statistic is statistic minus parameter divided by standard deviation. Right, well, we have the standard deviation. We know what the statistics are. We know what the parameters are. Let's plug everything in. So we get Z equals P hat 1 minus P hat 2 parentheses, minus P1 minus P2 divided by this whole standard error. So then I'm going to put P1 times Q1 over M1 plus P2. And be careful here. Make sure you're using P and Q, not P hat and Q hat in your denominator. Over N2. Okay. And a couple things to notice. P1 minus P2. Well, we said that if we combine them, we know that P1 minus P2 is just 0. And so this is just going to disappear. So I can kind of just not worry about this guy. Okay, so I'm left with, and if we combine everything, we have P hat 1 minus P hat 2 minus 0, but I'm not going to worry about that, obviously, divided by the combined ones, P hat C times Q hat C over N1 plus P hat C times Q hat C over N2, and those are all square rooted. All right, so now if you go back to the tattoo problem, if you combine our results together, what you get is you get P hat C is equal to 32 out of 60. Okay, and so that comes from up above, if you just look at the table. Okay, we're looking at success as being yes, so 32 out of our total being 60. Right, so 32 out of 60. That's what that comes from. So that's our P hat combined. And so now, now see if you can go ahead and see if you can figure out the rest of it, right? So we know what P hat 1 is. We know what P hat 2 is. You can read that from the table. We know what P hat combined is. We know our ends. So see if you can take a second and see if you can calculate the z-score. You should get a z-score, a negative z-score. And again, we can kind of go through the actual calculation in class. But yes, now that you know what P hat combined is, and again, I just took these from the table, so reading the table is going to be important. You can find P hat 1, you can find P hat 2. We already talked about earlier, and you can kind of go from there. Okay, so now the next one is it okay to use a calculator? Yes, it is. Again, we're going to set everything up. We're going to do the state plan to conclude, and then we'll use our calculators. So on the Inspire menu, stats, stat tests, two proportion z-test. Okay. On the 8384s, you're going to go stat, test, two proportion, z-test. So now read this next problem about headphones and see if you kind of come up with a solution to this question in part A, right? What can we say about the study just based on what the information given? And if you can say anything at all, right? So think about that. Okay, so last thing, do these provide a convincing evidence that all teens have hear loss? Again, try this out. See if you can find a P hat combined. Again, we'll go through this whole problem together in class. But yeah, see if you can kind of come up with a P hat combined. You know a P hat 1 and a P hat 2 from the problem, 50 and 19.5. And yeah, see if you can come up with a solution. And the thing is, make sure when you're writing these out, just kind of define everything. Make sure you kind of keep track of what's what. Because when you subtract P hat 1 and P hat 2, if you flip it around, it may be a little different. So make sure you're reading the problem carefully as you go through this. But that's it for the 10.1 video notes. Yeah, stay tuned for the next set. Because as always, if you have questions, let me know. But have a great rest of your day.